Good morning, student. This is the lecture number 26 of unit number 4, that is flow measurement. In flow measurement, we will have to study two parameters, that is flow measurement and force measurement. And in force measurement, we will have to study the torque measurement also. Okay. In the previous lecture, we have studied the orifice plate and flow measurement by using orifice plate and flow measurement by using venturimeter. In case of the venturimeter, we have studied how the discharge is calculated, how the convergent and divergent section of the venturimeter works, how the pressure difference is calculated in case of the convergent and throat section. Okay. uh, Different advantages and disadvantages related to venturimeter. We have studied uses of venturimeters. We have studied, that is, which is used for the industrial applications for waste gases, slurry, and dirty liquid suspend particles. Means flow of this. In these cases, we can measure by using venturimeter. Then next device we have studied, that is orifice plate or orifice plate meter. Okay, so there are four types of orifice plate meter, that is concentric, eccentric, segmental, and quadrant type. Okay, so out of that, one type of orifice plate we have studied, that is circular orifice plate. Okay, in circular orifice plate, how the discharge is calculated by using continuity equation, and the velocity is calculated by using Bernoulli's equation, that we have studied. Then in addition to that, we have studied advantages and disadvantages of orifice plate over venturimeter. Okay, then we have studied the difference between venturimeter and orifice meter. Okay, then next, today we will have to study the flow measurement. Okay, by using nozzle. uh, Generally, um, you may observe that, or you may have experienced that when we are watering to the plant or watering on the flower. What we will do, we just connect the pipe to the tap, and at the end of the tap, we put a thumb on the end of the pipe, so that what will happen, the area of that water flowing pipe is decreases, means from a higher area to lower area, so that the velocity, means it will act as a nozzle, and velocity of the flow of fluid will be increases. Okay, once we have lift that thumb from the end of the pipe, the velocity of the flow of fluid through the pipe will decreases. Is it? Means you most of the time realize or experience that, means once the area of the flow of water will be decreases, it will act as a nozzle. The similar principle will be applicable here also. So in this diagram, you can observe that this diagram is divided in two sections, that is section 1 and section 2. In between section 1 and section 2, there is a nozzle is fitted. So here we can see that the nozzle level is given in the diagram, where the diameter is d2. Okay, means what we can say, that as the diameter is decreases from d1 to d2, means uh, the area also decreases, because in relation to that, area is nothing but pi by 4 d square. Okay, so that's why we can say that the area is decreases. Okay, so as area is decreases, velocity is increases. Okay, so in engineering practice, nozzle are used for the creation of jet and stream for all purpose, as well as for fluid metering. When placed in or at end of the pipeline at metering device, they are called as a flow nozzles. Means generally, that what is the application of flow nozzle is that to create the jet and a stream for all purpose, as well as the fluid metering devices. Okay, then in fact, The flow nozzle is nothing else but a venturimeter without its diverging section. Means there is a converging section but there is no diverging section. Okay, so it differs from an orifice meter in the sense that it made curve. Okay, so that the jet contraction is not as large as in case of the orifice meter. In case of the orifice meter, what we do, just we put a, a, a flat bed having hole. Okay, that's why also the velocity decreases, means flow fluid having low velocity, sorry, high velocity. Okay, so that figure 4b3 4.b.3 shows the flow measurement by using a nozzle. The flow nozzle comprises a smooth, gradual contraction to the throat, followed by a free, uncontrolled expansion back to the original pipe flow area. Okay, in a nozzle, the flow is guided smoothly to the section of minimum area. The flow nozzle comprises a smooth, gradual contraction to throat, followed by a free, uncontrolled expansion back to the original pipe flow area. Means what? Here in the diagram we can see that there is a gradual decrease in the area. Okay, because at the nozzle section there is a gradual decrease in the area. Okay, that's why flow nozzle compresses a smooth and gradual contraction to throat, followed by a free and uncontrolled expansion back to the original pipe flow area. Okay, and which is given by the equation for discharge through a nozzle is given by Q actual, that discharge is equal to A2 into CD. CD is nothing but the coefficient of discharge. A2 is the area of the section 1 uh, divided by square root of 1 minus A2 by A1. A1 is the area that what we can say that convergent area. A2 is the nozzle area into square root of 2g into P1 minus P2. So P1 minus P2 is nothing but the pressure shown in the limbs. In the upward section of that pipeline, you can observe that two limbs are there which is connected to the manometer. Okay, for the measurement of pressure, and um, what we can say that the difference in the rise in the manometer limb or manometer rise in the rise of mercury in the limbs of the manometer, and the difference between them is nothing but h. Okay, so p1 minus p2 divided by w is the specific weight of the mercury. Okay, so this is nothing but the calculation of actual discharge through the pipe by using a nozzle. Okay, so there are advantages over the orifice and venturimeter for flow nozzle that have higher coefficient of discharge than that of the orifice meter. Means in this case we will obtain the higher coefficient of discharge. Okay, cheaper and easier to install, and physical length is less compared to venturimeter. Okay, we know that the venturimeter has a convergent section, nozzle, throat, and divergent section. So because of that, the length of the venturimeter increases. But as there is no um, divergent section in case of the nozzle, so the length of the meter that nozzle will decreases, means cheaper and easier to install, and physical length is less compared to venturimeter. Okay, so widely used for high pressure temperature steam flow. Okay, means wherever the higher pressure and temperature is there, in that case that venturimeter is widely used, sorry, nozzle is widely used, being more rugged and more resistance to erosion than the sharp edges orifice, because in case of the orifice we know that only flat plate is there having central hole, so because of that the sharp edges is there. But in case of the nozzle there is a smooth and gradual contraction to the throat. Okay, so they can be used for flow measurement at high velocity also. Okay, so there are some limitation of the nozzle is Owing to poor pressure recovery, they are not useful for applications where pressure head are small or where pressure recovery is must. Okay, as compared to orifice meter, it is expensive and difficult to install. Okay, and limited moderate pipe size, not applicable above 120 centimeter. 12 means 1.2 मीटर पेक्षा जास्त जर असेल पाईपची लेंथ वी कॅन नॉट use that nozzle for the pressure head. Then higher maintenance, maintenance in case of the nozzle is high. Then next one, I think you all of you got or you understood what is nozzle flow or flow nozzle for the measurement of flow fluid. Okay, then next is the pitot tube. The pitot tube in diagram you can observe that which is applicable to which is applicable to which is applicable to uh, wherever the pressure is to be measured. Okay, so this fluid velocity meter measures the local velocity at a point in the duct. Means it is only applicable to measure the local velocity. Okay, and is used mainly for the measurement of air or gas velocities. Okay, the velocity distribution across a section can be obtained with the help of a pitot tube, which is one of the most accurate devices for velocity measurement. Okay, means important and accurate device for the measurement, that is nothing but the pitot tube. Is it? Then we shows the schematic arrangement used for the measurement of static and stagnation pressure. Out of that, we will go for the static pitot static tube. Okay, so the question related to pitot static tube is asked in the exam, that is winter 13, summer 13, winter 8. So in case of the pitot static tube, okay, it consists of two concentric pitot tube with a annular space in between as shown in figure. Okay, the outer tube has additional two or more holes drill perpendicular to the direction of flow, and thus the liquid level in it gives the static head, while the inner tube works as a normal pitot tube. If a differential manometer is connected to the tube of the pitot static tube, it will measure the dynamic pressure head. Okay, so if y is manometric difference, then delta H equal to y into Sm by S minus 1, where Sm is the specific gravity of manometric liquid and S is the specific gravity of the liquid flowing through the pipe. The specific gravity of manometric liquid, because in manometer mercury is present, and S is the specific gravity of liquid flowing through the pipe. Okay, when a pitot static tube is placed in the fluid stream, okay, the flow along its outer surface gets accelerated and causes the static pressure to decrease. Okay, so when a pitot static tube is placed in the fluid stream, the flow along its outer surface gets accelerated and cause the static pressure to decrease. Is because of that the static pressure of the means when the flow along its outer surface gets accelerated, the static pressure decreases inside the pipe. Okay, so also the stream which is perpendicular to the flow direction tends to produce an excess pressure, and the velocity at any point p is given by v equal to square root of 2g into delta h. Okay, so which is nothing but for the measurement of velocity. Okay, so advantages of the pitot static tube: less costly as compared to venturi or orifice meter, easy to install and remove from the pipeline, negligible loss of head, when pitot tube is inserted in the pipe. Disadvantages: poor accuracy, unsuitable for dirt or sticky liquid, because in case of the venturi meter, we can use the sticky dirty liquid also for the measurement, flow measurement. Okay. And required high flow velocity of above 15 meter per second to produce a measurable head. Okay. So next is cannot be used for industrial application, which requires an instant readouts. Okay. So that's why that flow nozzle is, or static pitot tube. Pitot static tube is not applicable in case of the industrial uses. Okay. So the next one is the turbine flow meter. Turbine flow meter is also number of time asked in the university exam. That is winter 16, summer 16. Okay. In case of the turbine flow meter, uh, two horizontal lines you can observe, means above and below the uh, rotor. Okay. Rotor wheel, that two lines representing the cross section or transverse section of the pipe through which the fluid is flowing. Okay. And by using the arrows you can understand the direction of flow of fluid. Okay. Direction of flow of fluid. Okay. And that rotor wheel having blades, there are 8 blades are there, and on one of the blade there is a magnet is attached. Okay. So when when the flowing fluid is flows to the pipe, what will happen, that rotor wheel will rotate in anti-clockwise direction. The rotation is also represented there. So when it will rotate in anti-clockwise direction, uh, the the number of times that magnetic blade, or the blade on which the magnet is mounted, which will uh, come closer to the coil which is provided outside the pipe. Okay. So the number of time the pulse frequency is generated. Okay. And which will be the representation of measure of flow. Okay. So in details we will go on through that for the turbine flow meter. Okay. So a turbine type flow meter operates on the principle that when a turbine wheel is placed in a pipe, the containing of fluid flowing, its rotary speed depends on the flow rate of a fluid, and the speed of a turbine varies linearly with flow rate. Okay. If the bearing function friction is reduced and the losses are kept to be minimum, this flow meter is known as a inferential meter, because the operation depends upon the rotating form of the turbine and the stream velocity of the liquid in which it's rotate. Okay. So these meters are volumetric flow meters and are available in wide ranges. The turbine flow meter consists of freely rotating wheel with multiple blades. Okay. The rotor, supported by ball or sleeve bearing, is located centrally in the pipe along with a flow occurs. Okay. The flowing fluid impinging on the turbine blades imparts a force on the blade surface and sets the rotor in motion with an angular speed proportional to the fluid velocity. Okay. The rotor speed is measured with a mechanical counter or with an electromagnetic pickup and associated with counter. Okay. As the magnetic as the magnet moves past the coil, an EMF is induced. Faster the fluid flow, the greater the counter per second. Each pulse represents a definite flow quantity, and the total number of pulses may be taken as the induction of a total flow. Okay, so the volume flow rate is given by F by K. That Q is volume flow rate, F is pulse frequency, K is flow coefficient. It depends on the flow rate and viscosity. Is it? F is nothing but the pulse frequency. K is flow coefficient. Depends on the flow rate of the viscosity and viscosity. Okay. So the advantages of turbine flow meters are easy to install, maintain good dynamic response, then low pressure drop, good temperature and pressure rating, good accuracy and excellent repeatability, wide range commencing from 0.3 lpm to 15 lpm for the liquid, 3 lpm to 5 lakh lpm for air, adaptability to flow totaling and to digital bleeding system. Okay, so disadvantages: relatively high cost, error may be caused by excessive frictional torques, limited use for the slurry applications. Okay, so these are the different advantages and limitation of the turbine flow meter. Okay, so in the next lecture we will go for studying the variable area meter, that is rotameter. Okay, that rotameters are there. Then next variable flow meter is a special flow meter, that is hot wire anemometer, that we will see in the next lecture. Okay, so today we will stop over here. Whatever the doubts we have, that we will discuss in the Google Meet. Okay, so today we have covered the three topics, that is flow nozzle, then Pitot tube. In Pitot tube we have studied the Pitot static tube and turbine flow meter. Okay, so all the three instruments are used for the measurement of flow of a fluid flowing through the pipe, and every every instrument is having certain advantages and disadvantages over one another. Okay, so depending upon the different advantages, different instruments are applicable wherever the suitable conditions are there. Okay, so this is nothing but the flow measuring devices.